So constant is the same thing as constant rate of change or slope. I would make sure I write this down. And direct variation is a linear equation, just like we've been working with, y equals mx plus b. The only difference is that b equals 0. So for direct variation, we write our equations like this, and that means that the graph, where does it cross the y-axis? Yeah, and I'm going to put that it crosses the point 0, 0. What do we call that point?
The origin.
The origin, good job. So all of the graphs that we worked with today are going to go through the origin, or the y-intercept is going to be 0, okay? So the first thing that we have to do is find the constant of variation for each graph and write an equation. But remember that the constant of variation is the same thing as slope. So can we look at this first graph and figure out what the slope is? What is it? My slope is 2 over 1. And the equation of this graph is y equals 2 over 1, or just 2, times x. And it's actually written right here for you. So this graph has a constant of variation, or a slope of 2, and it's the equation y equals 2x. So now I'm going to call it what this lesson calls it, constant of variation. So what is the constant of variation? For example, b. What is the constant of variation? For example, b, meaning what is my slope? Go ahead, Tyler.
1 over 4.
So remember, we do the up and down first. So it goes down 4 over 1. And since it's going down, it's going to be, yep. So negative 4 over 1, which is the same thing as negative 4. So my constant of variation is negative 4. And that makes sense because the equation that they give us right here is y equals negative 4x. So we could really look at our equation and figure out what the constant of variation is by looking at the number attached to the x, by looking at the x coefficient, correct? Does that make sense? So why don't we do that? Why don't we just look at the equation given and figure out what the constant of variation is? So for example, C, the constant of variation, equals what? It's the equation y equals negative 2x. So the constant of variation, remember, which is the slope, is just negative 2. Okay. Let's do it one more time. What is the constant of variation for this graph? It's 3, because I have the equation y equals 3x. Okay. So someone tell me again, what is constant of variation? It's the what? The constant of variation is the, Maddie, it's your slope. It's the slope, it's the slope, it's the slope. That's what it is, okay? So now we're going to graph some equations. So when we graphed y equals mx plus b, where did we always begin? When we graphed the equation y equals mx plus b, we always began with what? You begin with b, correct? In these equations, what is the value of b, Jane? It's the origin. It's 0, 0. And my slope, or my constant of variation, is 4. So that means from the origin, I do what? Up, start at 0, go up 4 over 1. Up 4 over 1. Up 4 over 1. And I just keep doing that, right? When I'm done, I need to make sure that I connect my points with a line, and I put arrows on the end of my line. This is not a dot to dot. We aren't doing segments. We are doing lines. Lines have arrows at the end of it. Okay. So example number 3, where are we going to begin? We always begin at B. What's the value of B here? It's 0. What is my slope? -3 over 2, which means that I go down 3 and to the right 2. So I'm going to begin at the origin, and from there I'm going to go down 1, 2, 3, and to the right 2. Down 1, 2, 3, and to the right 2. Down 1, 2, 3, and to the right 2. Then I'm going to connect my points with a line and make sure I add arrows. Okay, example number 4. I know that I begin at 0 because it's a direct variation graph. What is my slope? It's -1. That means I go down 1 and to the right 1. Begin at 0, down 1 to the right 1, down 1 to the right 1. Connect your points with a line. The last graphing example, I'm going to begin at 0, and what is my slope? Or my constant of variation? 1 over 3. Because 1 is positive, that means I go up and to the right 3. Begin at 0, up 1, to the right 3. Up 1, to the right 3. Up 1, to the right 3. Same thing, down 1 to the right 3, down 1 to the right, or to the left 3, and I'm going to connect all my points with a nice line and put arrows on the end of it. So I think that's the easy part about the lesson. And I know that the next section says homework, but really we're going to extend our homework to our notes. It's still up there. Look. Yeah, we're going to keep working though. So go, be quick. Sign out for me, please, and thank you. Thank you, Jaden. Parker, thank you. So I just want to make sure that we know a couple of things. We know that direct variation graphs pass through what? Where do they go through? They pass through 0, 0, or the origin. I would write that down. You might see that question later. So they pass through the point 0, 0, which is called the origin. Okay, that's the first thing. The second thing that we know is that direct variation graphs, the equation is just y equals m times x. Okay, we write them as y equals m times x. So we're going to take that knowledge that we have of direct variation and of slope, and we're going to apply it with word problems, because I told you guys on Tuesday, we're kind of just really focused on word problems this week, right? We're just working on word problems. So we're going to start with our homework. We're really going to do some problems together. Okay. So I want to write some steps off to the side. So the first thing that we need to think about is finding our slope. That's the first thing that we need to think about. Okay. So I would write that down. Edward, I want you to go next door. I was supposed to send you about a minute and a half ago. I'm sorry. So is someone going to fill out his notes for him? Maybe. If not, we can fill them out when you're all done. You're perfect. Thank you. So the first thing that we're going to do is find the slope. So someone tell me what slope is. How do we find slope? We use the change in what? Yes. The change in the what? The rise over the run. So the rise is the change in the y over the change in x. Do you guys remember that? So we're not given an equation and we're not given a graph, but we are given coordinates. We know that if y varies directly as x, that when y is 9, x is -3. So that means that my slope is y, which is 9, over x, which is -3. So can someone tell me what my slope is? What is 9 over -3 when I reduce it? Yeah, my slope is -3. So we've done the first part. We found slope. The second thing that we need to do is we need to write an equation that looks like this: y equals m times x. But we're replacing the m with what we just found. So what did we say m was? It's -3. So our equation is now y equals my slope, -3 times x. And this is the direct variation equation. Notice that it doesn't have a b. We don't put a plus anything because b is 0. So we used the x and the y that was given up to us to find the slope. And then we turned that into an equation. So first we found slope by putting y over x, and then we wrote an equation. Okay? Now that's the easy part. That's the easy part. The third thing that we have to do, and this is where everyone kind of gets crazy, is we plug in x or y. You're going to be given one of those values and solve. And we do that using your equation that you just wrote. So that we do that using your y equals mx equation. So this is our y equals mx equation that we're using because it says use the direct variation equation that you just wrote. So I'm using y equals -3x. And it says, what is the value of x? We're trying to solve for x when y equals 15. That's the same thing as saying evaluate or let y equal 15. How do I solve that? Yeah, I'm going to plug it in, first of all. Yes, Parker. So y is now 15. 15 equals -3x. And Parker said, well, just divide that by -3. And 15 divided by -3 is -5. would like to do one more example. I want you to have really good notes because your homework really is interactive, and I want to make sure you know how to do it. So we're using these same steps. First, we're going to find slope, then we're going to write an equation, and then we're going to plug it in. So let's do it again. So first, we are going to find slope by letting m equal the change in y over the change in x. So what numbers am I plugging in here? What is the y value and what is the x value?
28 and 7.
So 28 over 7. What does 28 over 7 reduce to? Reduces to 4. So 4 is my slope. Okay. So we did the first part. Second, we're going to write y equals mx equation, but we're replacing the m with what we just discovered. So what is our direct variation equation here?
Y equals 4x or 4x.
Y equals 4x. So y equals 4x is the direct variation equation. I know that this is going to cross the y-axis at 0 or pass through the origin, and I know that it has a slope of 4. That's what I know about this. Okay? And then the third step is to use the y equals mx equation, and you're going to plug in x or y, depending on what they ask for, and then solve. Okay? So I have to use this direct variation equation. I have to use that direct variation equation. So I'm taking this equation that I just wrote, and I'm going to put it right here. Okay? And it says, hey, find x. That's the same thing as solve for x, right? Solve for x. When y equals 52. So I have to let y equal 52. So I'm going to replace the y in my equation with 52. So 52 equals 4x. I'm trying to solve for x. So what do I do? Divide both sides by 4. Thank you, Hayden. Divide both sides by 4. 52 divided by 4 is 13. 13 equals x. Okay. So you have like 2 questions left on your paper homework, but you have 2 interactive practices in Canvas. Now, I will tell you that if you follow the steps, your interactive practice is super easy. But if you don't follow the steps, it's tough. Questions?
Can I use the bathroom?
Yes, you may. Will you sign out for me, please, and thank you?